Coin Combinations, the first version. So I'm not going to read the instruction, but essentially what we need to do is we have a bunch of coins, almost 100 coins that have distinct, they are distinct in their value. So it's distinct, we have distinct integers here. And we want to create a certain sum x that goes up to 1 million. So what we're going to do is just reuse all the subproblems by choosing the last coin that we are going to use. So if the last coin that I'm going to use is C1, for example, let's just draw this. So let's say we have C1 up until Cn, and we want to calculate the result for dpi. We are going to, essentially for each coin that we have, we're just gonna go and look at dp I minus the coin we're looking at right now. So for C1, we're looking at dp I minus C1, and for Cn, we're going to look at dp I minus Cn. And by combining these solutions and adding the results we have for these solutions, we can get the solution for dpi, right? So essentially each time we pick the last coin, and that last coin is going to move us backwards by the value that it has. So if the sum that I'm looking at is I, by utilizing coin C1, I know that I need all the solutions that lead up to a sum of I minus C1, because C1 is going to be the last coin I'm going to use, and it's going to add into that sum. And when we add into that sum, we want to reach sum I. So obviously I minus Ci, which is the last coin that we are adding, by adding Ci to it, is going to give us what? Is going to give us I, which is the sum that we are looking for. We're searching the answer for, and that's pretty much it. So because the order plays a role in counting the solutions, we also take into account essentially we need to take into account the last coin, right? And that's pretty much it. That's the observation we need to make. And let's go ahead and look into the implementation. Again, we have 100 coins and 1 million and 1 positions here. That's the DP of the sum using zero-based indexing. So we read n, the number of coins, x, the sum we want to create. We just read it here, and then we read the values of the coins that we have, and then we know that for a sum equal to 0, there is only one way to create this sum, and that's the way in which you are using no coins. If you use no coins, then you have a sum of 0 essentially, right? So there is only one way to have this sum. And then we go through all the sums. So the value of the sum essentially points to a certain subproblem, right? So we begin from the smallest, which is 1, up until x. We already have the solution for 0, right? And then for each such subproblem, as we have seen here, we are going to iterate through all the coins and see and get the solution for the subproblem minus that coin, right? So here, what do we check with this if statement here? We check that by subtracting that coin from our current sum, we are going to have a value that's greater or equal to 0. Because otherwise, if the coin has a value greater than I, then the coin itself is greater than the sum that we want to achieve, so we cannot use that coin. And then what do? We add into our solution for subproblem I, which is initially it is equal to 0 because this is a global array. We just add the solution to I minus that coin that we are going to add last, minus the last coin we are going to use, right? So we are using the solution to that subproblem, and we are adding the number of ways that we had for this subproblem. We are adding it to our current subproblem, since we can just utilize this coin J, right? And then we just modulo the answer to this problem and we output the answer. So that's pretty much the solution to coin combinations. If this video helped you understand how this simple DP problem is solved, please leave the video a like, subscribe to the channel, and I will see you in the next video.